In 1983, a comet capable of causing extinction-level destruction made a close approach to Earth. Worse still, the object was only detected a few days before its nearest encounter, which translates to just days of preparation if an apocalypse was about to occur. NASA said that if a big asteroid headed towards our planet, we would need at least 5 to 10 years in advance to carry out defense measurements. Although the odds of major impacts in the near future are relatively low, it is almost certain that one will eventually happen, sooner or later. It's just a matter of time before planetary avoidance systems need to be undertaken, or humanity's fate would be similar to that of the dinosaurs 66 million years ago. However, it's not just large asteroids that create problems. In 2019, an asteroid big enough to destroy a city, traveling at the speed of 90,000 kilometers per hour, was only spotted less than 24 hours before its closest approach, where it flew 5 times closer to Earth than the Moon. A fireball crashed into the Earth's atmosphere and exploded in the middle of the sky, with completely no prior warning. The explosion generated more than 30 times the energy released from the nuclear bomb detonated in Hiroshima, damaging buildings, blasting windows, and injuring more than 1,000 people. In reality, almost all asteroid collisions that happened were not forewarned at all, or alerted less than 24 hours before the impact. But the truth is, asteroids are very hard to detect. Space is unimaginably vast, and we are surrounded by thousands of near-Earth objects. Humans rely on telescopes to observe these space rocks, but small ones are incredibly difficult to track, even with advanced technologies. To make matters worse, since asteroids are very dark, we can only see them when the sun directly lightens their surface, which means that a huge number of asteroids haven't been detected yet. These object sizes can range from a few meters to even several thousand meters, which are classified as extinction-class asteroids. So what could we do if there's a large asteroid heading towards the Earth now? Well, the answer is, to this day, we can do absolutely nothing. Humanity has yet to establish any method powerful enough to push an asteroid out of its trajectory. But we have time to prepare and develop our technologies. There are several proposed solutions to defend our planet from an asteroid. First of all, a solution everyone comes up with: nuclear explosions. A nuclear detonation could vaporize part of the asteroid, heating material into ejecta, which could create a rocket engine effect and push the object towards the opposite direction. This would be expected to change the asteroid's orbit by an amount enough to miss the Earth. In fact, NASA's spacecraft called Hammer, which can set off an atomic bomb to deflect an asteroid, has already been studied and tested. Another approach is called kinetic impact, which uses a spacecraft or an extraterrestrial body to directly collide with the hazardous asteroid. We could aim a smaller asteroid towards the dangerous one to knock it off course or smash a specialized spacecraft into it. This actually happened in reality. In 2005, the Deep Impact spacecraft intentionally crashed into a non-threatening asteroid and successfully altered its path. On the other hand, both nuclear explosions and kinetic impacts have the risk of breaking the asteroid into smaller fractures, which could clear away our effort since gravity would pull them back together. Thus, these approaches can only be used with solid asteroids. Therefore, we can use a less violent concept, such as conventional thruster or a mass driver. We can attach a powerful thruster to the asteroid's body or construct a mass driver on the surface to extract and shoot material into outer space, driving the object as we want. Because these devices are fixed, it is incredibly hard to control asteroids as they are spinning, so it might take years or even decades before a significant effect can be seen on the asteroid. Luckily, astrophysicists have developed these concepts to direct them without making contact. The first idea is to run a gravity tractor, which consists of hovering a massive spacecraft over the asteroid. The gravity will pull them together, but the craft would counter the force using a thruster, so that the overall result would be the asteroid accelerating towards the spacecraft. The second idea is an ion beam shepherd, which works like a two-way thruster. The first engine creates the propulsion to move the asteroid, and the opposite one serves as a balance booster to prevent the spacecraft from crashing into the surface, so a net force would act on the object to drive it forward. While these techniques might be slower than the others, they have no difficulty dealing with fast-rotating and vulnerable asteroids that cannot work with other methods. For lower-mass asteroids, laser or focused solar power has been suggested to be exploited. Ideally, these can work with small asteroids that have a short amount of prior warning time, but both of which bring significant engineering challenges that cannot be solved with our current level of technology. Fortunately, the chance that a rock like this collides with our home soon is extremely small, probably about once in a million years. Plus, big objects are relatively easy to keep track of, which means we have time and near-term safety. But asteroid impact avoidance strategies are always needed for small-scale space rocks that are too insignificant to be watched, yet can pose a threat to cities and even countries. We better hope for the best and prepare for the worst.